So please give it up for Krystal. All right, so hi everyone. My name is Krystal and I work as a staff front-end developer at a startup called Human First. And today we are going to talk about how a bare bones design system can help speed up development for small teams. Before Human First, I actually worked for almost 5 years at Shopify, a company that by the time that I left had around 10,000 employees. And during my time there, I dedicated a good chunk of time working on design systems, especially Polaris Viz, which is a React-based data visualization design system that we open sourced before I left. And this was a very rewarding experience to me because I could see how having a strong foundation and the building blocks ready to be put together actually allowed the team to have to spend less time reinventing the wheel and had more free time to do the innovative and creative work. So I decided to leave a 10,000 employee company to join Human First that has 20 employees. But one of the main reasons why I decided to do this move was because I was baffled to see how such a small team was actually managing to make an impact in some of the largest corporations in the world. So this got me thinking, how can I apply my experience with design systems and working in a big company to make this small but mighty efficient team be even more efficient? And one of the first things that I noticed was that UX on the application was not that great. And it was easy to justify that because none of the 20 purple dots on the screen was a designer. But before we talk about design systems, let's quickly go through what Human First does in the first place. So this is Bob. He's not a technical guy. He's not a data scientist. And he works labeling data that is later used to create chatbots for his company. Do you know when you call a company and then there's a recording that says this message is being recorded for whatever purposes? So those calls actually get transcribed into text and end up on Bob's spreadsheet. So all of the phrases of the conversations are there, and then he has to manually search for keywords on the huge Excel spreadsheets and then assign labels to the phrases. So this is Bob after a couple of hours of this tedious work. So you can see how, it's not the most interesting work in the world. So a colleague mentions to him that there is a tool that actually automates the kind of work that he has been doing, and he decides to give it a try. So this is the same workflow that Bob was doing in a spreadsheet in Human First. So we start by creating a cluster of phrases that have a similar meaning. Then I can quickly confirm that all of the phrases that the platform selected for me actually have a similar meaning. So we will tell me my interest rate. I want to know my interest rate. I have to find the interest rate of my checking account. All of those are actually similar. So I can go ahead and put them in my stash. And now that I do have a bunch of phrases that mean the same, the platform is suggesting to me that I apply the label, will you tell me my interest rate to those phrases. So it says that it has a 96% chance of being the correct label. So I can confirm that by quickly looking at what's already inside of that label. So what's the interest rate of my Chase credit card? What's the interest rate of my Barclays card? Could you tell me my interest rate? It all seems to be part of the same topic. So I agree with the tool. I can go ahead and put the phrases that I selected before into that label. And that's Bob again after using Human First. But jokes aside, you can see how having a platform cluster phrases by meaning and having the platform suggest the labels for me is much, much easier than manually searching for keywords on a huge Excel spreadsheet. So Human First drastically scales conversational data analysis and labeling. The work that would take him hours to do on Excel can actually be done in minutes using the platform. So what I just showed was the latest version of the Human First platform. And today we are going to talk about how we organize our work to get to this point. So let's go through a couple of examples. Take a look at these buttons, for example. By looking at them, it doesn't seem to be anything wrong, right? Maybe I could argue that the difference in size between M and L don't actually justify there being two sizes, but it doesn't look bad until we look at the underlying implementation. So what seemed to be a button was actually a div with a lot of JavaScript gymnastics to make it behave like a button. And this is a shame because we are losing a lot of the default functionality that an HTML button has for us. So things like being focusable via tab, clickable with enter and space, disabling the button when the disabled attribute is true, all of that that we get for free is not present there because it's a div. And it's especially a shame because if we use a button, the implementation would actually be simpler. Not to mention the accessibility concerns of an implementation like this, because it's a div, not a button. A screen reader, for example, would not be able to tell that it's an interactive element, or someone that is not able to use a mouse, for example, could not interact with a button only using a keyboard. And it might not seem much, but you can actually get sued for that. Beyoncé, for example, was sued a couple of years ago because her website was not accessible. And I love that it happened, because I can use her as an example every time that someone tries to deprioritize accessibility work. And I love it so much that I actually made a sticker. So every time that someone opens a pull request that has an accessibility issue, I use the sticker when I reject the pull request. So feel free to use the sticker too, absolutely important. So this brings me to principle number 1 of a bare bones design system, which is avoid JavaScript gymnastics. If you are using too much JavaScript to implement something that should be simple, you're probably doing it wrong. Okay, so I know that people tend to do things like using divs instead of buttons because the default styles of buttons are ugly. But you can use a simple mix-in to remove all of the default styles so that you have a blank slate to start styling, the same way that you would have with a div, for example. So feel free to copy and paste that too, so that you have all of the default browser styles removed, and you can apply your own styles to the buttons or form elements or whatever it is. So for comparison, this is what the new implementation looks like. We can take advantage of the native on-focus, on-blur, and on-click events. We are not reinventing the wheel, and no need to add any special JavaScript or CSS. We can just use the disabled attribute of the native button. Okay, so principle number 2, don't reinvent the wheel. This is a component that used to live in our application, and it's supposed to be a checkbox, and I absolutely hated it because it doesn't look like a checkbox. Interactive elements should have a tactile feel to them so that we know that they are interactive elements, and these look like SVG icons, which makes sense because that's what they were. So if we look at the underlying implementation, look at how much code is necessary just to implement something that we would get for free should we have been using the correct HTML elements for it. So by comparison, all of that can be replaced by this. And the bonus points with the more native approach to implementing something like this is that we can actually make sure that the label is part of the checkbox component, and that we have proper HTML4 linking the label to the input ID. Once again, good for accessibility. And we also make sure that our labels are consistent everywhere. Okay, principle number 3 is separating layout from elements. And to better understand that, we have to quickly talk about atomic design. So atomic design is a methodology that organizes design elements into atoms, molecules, organisms, templates, and pages. And it was created by Brad Frost a couple years ago. And it has since pretty much become the Bible when it comes to creating design systems in a scalable way. So atoms would be the smallest parts of your design system, so things like labels, inputs, and buttons. And these small parts are not supposed to be aware of where they're going to be used. So they should never have margins, for example. That's a layout concern. It shouldn't be on the atom level. Then we have molecules, which is what you get when you put atoms together. So in this case, the space, the gap space between the inputs and the button can be defined here because we do want to make sure that our molecules are consistent everywhere. And then we have organisms, which is what you get when you put molecules together. They are self-contained pieces of layout, like headers and cards of information, for example. And then we have templates, which mostly consist of groups of organisms stitched together just in a specific layout. And then we have pages, which is the final product with the actual real content. So if we were to translate that into React land, we could, for example, have a component called a stack that you could use to lay out components in a stack horizontally or vertically. We can also adjust the alignment and justify the elements in different ways using the stack. And this is what the implementation of something like this would look like. It's just a couple of CSS classes to make sure that our gap sizes are consistent and some inline styles so that we can align and justify the elements the way that we want. Another example of a template component would be a grid component. So here you can adjust adjust through props the gap sizes of the grid and also the sizes of the rows and the columns in the template. Yeah. And once again, this is what the underlying implementation looks like, just simple CSS classes and inline styles. But the nice thing about having components like this is that you can configure them to use the default spacings of your design system, which are defined in CSS variables, so that everything is consistent, while at the same time avoiding snowflake CSS. So CSS classes that are only used once in the application purely for design, for layout purposes. You can see that both the grid and the stack CSS classes use mixins to apply the same default gaps and paddings. So basically, they just apply the same CSS classes that use those CSS variables that specify how wide the gaps should be based on variables like space none, space extra small, space large, et cetera, et cetera. And the same thing is also true for the paddings that can be horizontal, vertical, and use the same spaces. On a more practical example of how such components could be used, let's take a look at this page. You can see that on the left there, we actually have a line dividing the left column to the rest of the content. I don't know if it's actually easy to see on this screen, but there's a line there, trust me. Yeah, and because each element of the column actually has a gray border, when we introduce a new element, that gray border is not there. We would need to add another Snowflake CSS class to that specific element just so that we have a continuous line, and that doesn't make sense. A much more easy approach would be to have a container element that has the gray border in a continuous line, and then use the stack elements to organize everything in a stack vertically inside of the column. So all of the children of the stack there would be the elements responsible for their own layout, for their own design, but the layout of the column itself is just a stack. The whole page could actually be laid out using the grid component. No need to have special CSS classes here. These layout components can also be smart too. For example, we have this creatable list component, which is a template component that allows us to add and remove generic key value pairs of items. A component like this, because it's not aware of the children that are going to be rendered inside, can actually be used to render different things. Like in this example, we are using it to render two text fields for a key and a value pair, and we can add and remove rows as needed. But we can also use it in a different form of the application that actually has a tag selector instead of a text field. Because the component doesn't care of what the children are going to be, we can use whatever, but the logic of adding and removing rows as part of the template is still there. Another good example of smart layout components is a horizontal collapser. So this component doesn't have any design, because its only responsibility is to measure the available horizontal space to see what fits, and then collapse what doesn't fit to be rendered when you click on a button. So a component like this can be used, for example, to render the menu of the application. So it's going to measure to see how many links fit in the available horizontal space, and what doesn't fit, it renders as the children of the button that is clicked in the dropdown. And this is how a component like this can be used. You just pass an array of elements and a function to render the elements that don't fit in the available screen space. So to recap, principle number 1 is avoiding JavaScript gymnastics. Principle number 2, don't reinvent the wheel. And principle number 3 is separating layout from elements. Yeah, that's all that I had for today. Thank you so much.